Hi, I'm Nora from the Smart Labs Ready Set Grow team. I'd like to explain how my software works. This is the Arduino IDE where we write our code. We use the C programming language. We can enter comments with a slash and star or double slashes. These includes are for the Polulu functions, for the buzzer and LCD. These codes are the notes to play the various songs. Use an array for the lights, inputs, and outputs. To make it easy, we define each function by the color, system, and team member. For example, Nick's system is green and is for the plants. Here are the arrays for the input pins and output pins. For example, the first pin is white. For white is input pin 20 and the output pin is 18. This will make things easier later in the program. These variables record the state of the system, on or off, and the counts that are used to determine the state of the system. I count each signal and need to have 10 signals for on and then 10 signals for off so we don't make a mistake. The pin for the gate button is 5, and the pin for the heartbeat is 13. Here are the variables for the program. Start time is when the heartbeat starts. Expected state is the on or off that we have sent out and are expected to see from each system. Max count is the number of ons or offs that we need to see change in the state. Max delay is the normal delay of the system in milliseconds. We're using 10,000 milliseconds or 10 seconds. The delay starts out at max delay. Here are my subroutines. Start clock changes the state of the heartbeat and turns the heartbeat, white LED and red LED to the same state. The exclamation point is a way to say not. So not false is true and not true is false. This way it just goes to the opposite. We set the start time to the current number of milliseconds from starting the program and then print the word monitor to the LCD. Next level is the subroutine used in the game when a level is passed. It reduces the delay time and makes the system run faster and faster. It prints the delay time for each player, if they are still alive. It then switches to extended state and sends the heartbeat in blue, green, and yellow LCDs. The setup is the routine that runs one time at the beginning of the program. It sets the modes for each pin. Heartbeat is an output and the game button is an input. This array initializes all the output pins and all the input pins with the arrays. Finally, we start the clock. Read state is a subroutine that reads the state of a particular input and will set the value of the output LED if the use-like variable is true. When a player is out of the game, we stop changing his light. Here's what I was telling you about counting. We need 10 ons to change the value to on and 10 offs to change the value off. It makes the signal much stronger and avoids errors when we have any noise. Finally, we write the system state to the light if the player is not out. System failure is the routine that gets called when one of the system fails. Just pass it the system number. Here, if Nick's system dies, we print Nick to the LCD and play Nick's song. We also write a message to the serial monitor. We wait until the song is finished and then start the clock. Here's the code for Maria, Shreya, the red button, and the white button. Wait for button is a subroutine for starting or ending the game and just waits until either the red button or the white button is pressed and then released. The loop is the main subroutine that just keeps running over and over. First, we read the demo switch. If we are in demo mode, we start the game. We print the Staying Alive message, turn all lights on, and play the song Staying Alive by the Bee Gees. We then wait for a button to be pressed to start the game. We clear the screen and set a maximum delay. Put both players as alive and advance to the next level. While either player is alive, note that the double vertical bars is our way to say OR using C. If we are past the delay time, we check each player. First, we check for red. If the red state is not the extended state, then we call the system failure for red. Then we check the white and play the system failure for white. We then go to the next level and pass the alive variables to indicate if we should display the message. Once both players are out, we display the game over message and play the game over music. We then wait for 2 seconds and then for a button press before we end the game. If we're not in the game, we always use the max delay time. We read each of the systems, Maria's, Nick's, and Shriya's. Once we've set the maximum amount of time, we check each system. If each system state is not equal to the expected state, we perform the system failure function for that system. Finally, we change the clock to the next expected state. That is pretty much it. It makes sure that each system is paying attention, like a game of Simon Says, and offers a game mode to see who is the fastest responder. The fastest we've gotten is around 250 milliseconds. Come to Robofest World Championship and see if you can beat the best time.